Students, today we'll see beta lactamase inhibitors. First we'll see what is meant by beta lactamase. Okay, so it is ending with ase. So by that we can say it is an enzyme. So what they are group of enzymes that are produced by bacteria. What is the role of this one? They inactivate the beta lactam ring. How beta lactam antibiotics? How it is inactivating that? It opens the beta lactam ring. Okay, so what they are group of enzymes. They are produced by the bacteria and they are inactivating the beta lactam antibiotics. How it is inactivating? It opens the beta lactam ring. So that's all about beta lactamase. Now we'll see what is meant by penicillinase. So many times we have come across the word penicillinase. So what is it? It is a type of beta lactamase, and that is showing specificity for penicillins, that is it hydrolyzes the beta lactam ring of penicillins. Now we'll see beta lactamase inhibitors. What they are not antibiotics and they are having weak antibacterial action and they inhibit the beta lactamase enzyme. How it is inhibiting that? It is preventing the bacterial degradation of beta lactam antibiotics. Okay, so and extend the range of bacteria the drugs are effective against. So now we'll see the role. Actually we have known beta lactamase, that is produced by the bacteria. So what is the role of beta lactamase? That one is inactivating beta lactam antibiotics by opening the beta lactam ring. So what is the role of beta lactamase inhibitor? That one is inhibiting this enzyme. So because of that, the inactivation of beta lactam antibiotics, that would be prevented. So that is the role of beta lactamase inhibitors. Now we'll see the classification of beta lactamase inhibitors. So based on beta lactam core, it is divided into two types. One is beta lactamase inhibitors with beta lactam core, another one is without beta lactam core. So first we'll see the drugs coming under, the examples coming under beta lactam core. Examples are clavulanic acid, sulbactam, tazobactam, tebipenem. And without beta lactam core, examples are avibactam, relibactam, vaborbactam. Now second one is based on the group present at position 1. So it would be classified into class 1 and class 2. Class 1 is having heteroatom at position 1 and class 2 not having heteroatom at position 1. The examples for class 1 would be clavulanic acid, sulbactam, tazobactam. And class 2, that would, examples are the carbapenems. That would be classified into two types, subdivided into two. One is first generation, another one is second generation. Examples of first generation, thionamycin, imipenem. For second generation, it is meropenem, biapenem. These two are newer carbapenems. Now we'll see the mechanism of action of beta lactamase inhibitors. There would be two mechanisms. One is transient inhibition, another one is mechanism based inhibition. Okay, so some inhibitors are working under transient inhibition. So the example is carbapenem derivative. Now we'll see this one. Already we have known beta lactamase inhibitor. So the beta lactamase inhibitors, they are having carbonyl group, and this beta lactamase enzyme, that is having active site, and in the active site is serine hydroxy group is present. Okay, serine, that is having OH. So the beta lactamase inhibitors that is having carbonyl group, that is binding with the hydroxy group present in the active site serine. Okay, so because of the binding, what happens? First, there may be formation of transient covalent bond, and finally acyl enzyme intermediate would be formed. Then this undergoes nucleophilic attack of water molecule. Okay, and on this attack, what happens? The beta lactam ring, that is cleaved and that would be destroyed and the enzyme would be free. Okay, this enzyme, this is going to attack some more substrates. So this is the general mechanism for transient inhibition. Now we'll see this mechanism. We have known the enzyme, in the active site it is having serine, that serine is having hydroxy group. This is the beta lactamase inhibitor that is having carbonyl group. So by means of that enzyme, okay, so first it forms the it is binding with that enzyme. How it is binding? Here the bond between carbon and oxygen, carbon and nitrogen, that would be broken, and this H is added with the nitrogen, and this is an enzyme with that O, that is added with the carbonyl group. So that's why we are getting that. This is called acyl enzyme intermediate. Then on hydrolysis, what happens? Here there may be cleavage and H is added with that and the enzyme is going, and here with the carbonyl group, what is OH is added. So this is the hydrolysis product. So this is the mechanism of transient inhibition. Now we'll see Now we'll see mechanism based inhibition. These three examples, no, they are working under mechanism based inhibition. What are the examples? Clavulanic acid, sulbactam, tazobactam. Now we'll see the mechanism. First, already we have known this, the beta lactamase is having active site, and in the active site is serine is present, and that is having OH group. Now the beta lactam carbonyl group, and the beta lactam inhibitors, no, that is having carbonyl group. So these three are having carbonyl group in the beta lactam ring. That one is binding with the hydroxy group present in the serine. First, it forms acyl enzyme intermediate. So first it forms acyl enzyme intermediate. So initially it acts as a progressive inhibitor. Then this is diverted by tautomerism to form an imine form, that is a more stable form. Actually first the inhibition, no, that is reversible, then later it forms a covalent bond. Then it is diverted by tautomerism to form an imine, that is a more stable one. So this is hydrolyzed more slowly to free the enzyme. So here this enzyme, this beta lactamase inhibitors, no, they are called as suicide substrates or suicide inhibitors. Why they are called suicide substrates? Because they get inactivated after binding to the enzyme. So that is the action. So what is the action? So first it forms acyl enzyme intermediate, then it undergoes tautomerism to form an imine one that hydrolyzes more slowly to free the enzyme. Okay, here the inhibitors, no, they are acting as substrates for the enzyme that they inactivate. That's why they are called suicide substrates or suicide inhibitors. Now we'll see the reaction. So we have known this is the inhibitor. So it is binding with that with the enzyme to form acyl enzyme intermediate. So same as that of the transient mechanism. So we got this. Now then it undergoes tautomerism. On tautomerism, the bond between carbon and this heteroatom, no, that is broken. So to satisfy the valency of nitrogen, double bond is coming here. So this is the imine form, and under cross linking we are getting inactivated form of inhibitor. So that's all. That's why they are called suicide inhibitors or suicide substrates. Now we have seen that class 1 inhibitors. Now what are the examples we have seen under that? Clavulanic acid, sulbactam, tazobactam. Here they cause prolonged inhibition of beta lactamases. That's why they are useful in combination with extended spectrum beta lactamase sensitive penicillins, and they are used to treat infections caused by beta lactamase producing bacteria. Okay, and we have known this one, that is beta lactam. What is the role of that beta lactamase? That one here we have known this is a beta lactam antibiotic that is having beta lactam ring. By means of beta lactamase, what happens? That one is cleaving the beta lactam ring by means of hydrolysis and makes it inactive. So that is the action of beta lactamase. So if the beta lactam antibiotics are combining with or given in combination with beta lactamase inhibitors, first what we are getting one complex, and that complex decreases the effectiveness of beta lactamase and enhances the activity of beta lactam antibiotics. That's why the beta lactamase inhibitors, no, they are given in combination with beta lactam antibiotics. So what is that? By giving that combination, what happens? A complex would be formed. That complex is decreasing the effectiveness of beta lactamase and increasing the activity of beta lactam antibiotics. That's all. Other points we'll see in next class.